All right, now we're going to look at number 8. Number 8 says a 100-kilogram commuter, so we're given that the mass is equal to 100 kilograms, is standing on a train accelerating. What is the coefficient of friction? Must exist for the commuter's feet and the floor to avoid sliding. So the commuter's not moving, okay? And I want to find the coefficient of friction. The key to this whole problem is the free body diagram. So I'm going to make, and again, I always want to draw my sign convention so I know what's going on, okay? Now, that's positive. So my weight acts down, my normal force acts up. So let's say the train is moving this way. The frictional force acts opposite. Is anybody pushing or pulling the commuter? Does he have an applied force? He's standing on the train. The train is accelerating. Is anyone pushing or pulling him, causing that acceleration? He's just standing on the train. So the whole key to this problem is there's no applied force. Nobody is pushing or pulling him to make him accelerate at 3.7 meters per second squared, are they? He just happens to be standing on the train, which is accelerating. So there's no applied force on the commuter. That's my free body diagram. Is this one free body diagram different than the other ones? It is. That's why you have to draw your free body diagram. So now we just go through the same steps. So right away, I see I'm given the mass. So I know that I need the weight, so F of G is equal to mg. So it's 100 kilograms times 9.8 meters per second squared. So that one I can do in my head. F of G is equal to 980 newtons. So that's his weight. Well, I don't know where to start. When you don't know where to start, you go to the end. So you write down, well, what am I solving for? I'm solving for mu. So I know mu is equal to F of F over F of N. Do I have F of F? No. Do I have F of N? No. So once I find those two things, then I can solve this problem. So what should I do? So I'll sum forces vertically. So summation of F of Y is equal to MA. Is this block accelerating in the Y direction? No, it's not even moving. So this is 0. And then in my Y direction, I have Fn, which is positive, minus F of G. So Fn minus Fg is 0. So Fn is equal to Fg. So Fn is equal to 980 newtons. The next thing I can do is I can sum forces horizontally. Summation of F of X is equal to MA. Is this block accelerating in the X direction? Yes, because they told me the acceleration, so it is not 0. So this is M times A. Now I'm going to replace this. What forces do I have going in the X direction? I only have one. The only force I have going in the X direction is F of F. And when you look at F of F, it's going negative, so this is negative F of F is equal to the mass, which is 100 kilograms, times my acceleration, which is 3.7 meters per second squared. Now, I have this on the other side, so I should probably move the negative on the other side. So F of F would be equal to negative, and this would be 370 newtons. So now, once I have F of F, and I have F of N, and the negative sign, I already have it negative in my free body diagram. So now I put all this back into my mu equation. F of F is 370 newtons. F of N is equal to 980. My newtons cancel, and 370 divided by 980 comes out to be 0.378. Is this between 0 and 1? Yes. And that's it. So again, on all these problems, I have 3 things I'm going to do. After I write my given, I write what I want to find, I draw my free body diagram. After my free body diagram, there's 3 things I'm going to do. I sum forces horizontally, I sum forces vertically, and I use the mu equation. If I do it in the wrong order, then I say, well, I need to find this and I need to find that, and I just do the other ones and then go back. So there's not going to be an excuse, I had no idea what to do, because you're going to do these 3 things on every single problem, and that's it.